Question 2, Part B. The function f of x equals cos 2x minus x has a 0 near x equals 1 over 2. Use one application of Newton's method to obtain another approximation to this 0. Give your answer correct to 2 decimal places. I've sketched a diagram to visualize the application of Newton's method to find a better approximation to the 0 of f of x than 1 over 2. So we're given that 1 over 2 is close to the 0, and the idea of Newton's method is to come up with a value that's even closer to the 0 than 1 over 2. The way we're going to do that is to locate the point on the curve where x is equal to 1 over 2, get the y coordinate at that point, and then draw the tangent to the curve at that point that we just found, and then find the x-intercept of that tangent, and the x-coordinate, or the x-intercept, should be a better approximation to the 0 of f of x than the original value 1 over 2. So we need the y-coordinate of point A, which is the point directly above 1 over 2. And we get that by substituting 1 over 2 into the original function. So substituting 1 over 2 for x here and here, we get the y-coordinate of A is cos 1 minus 1 over 2. Next, we need the gradient of the tangent at point A, and that's given by f dash of x. So we get that by differentiating cos 2x minus x with respect to x, and we need to apply the chain rule to differentiate cos 2x. So f dash of x is equal to negative 2 times sine 2x minus 1. So the value of the gradient is found by substituting 1 over 2 for x in f dash of x. So f dash of 1 over 2 is equal to negative 2 times sine of 1 minus 1. Now point B, that's this point here, is the x-intercept of the tangent to the curve at A, and we want the x-coordinate of B, of course, so we know that the y-coordinate is going to be 0, and that's an approximation of the 0 of f of x. Next, we need the equation of the tangent at A, and we get that by applying the point gradient formula. Y minus y1 is equal to m outside of x minus x1. So in this case, that's going to be y minus cos 1 minus 1 over 2 in brackets is equal to negative 2 times sine 1 minus 1 in brackets times x minus 1 over 2. Now we need to solve this equation for x given y is equal to 0. And that'll give us the x-coordinate of point B, which is the approximation of the 0 that we're looking for. So letting y equal 0 here, so we're solving negative cos 1 minus 1 over 2 in brackets equals negative 2 times sine 1 minus 1 in brackets times x minus 1 over 2 in brackets. Rearranging this equation to make x the subject, we get x equals negative cos 1 minus 1 over 2 in brackets divided by negative 2 times sine 1 minus 1 in brackets plus 1 over 2, and that gives us x1, which corresponds to the x-coordinate of point B, and that's equal to 0.5150 and so on. And rounding this value correct to 2 decimal places, we get the approximation to the 0 is 0.52 correct to 2 decimal places.